Hello everyone. In this video, we're going to be covering topics from the course of Chemistry 1411, also known as General Chemistry 1. So the topics that we're covering today are going to be polyatomic ions, bonds, and isotopes. So here is a list of the polyatomic ions that you're most likely going to have to know. Some professors require a few additional, some have a few taken off. However, this is a good list of the ones that you have to know for your exams, and if you have further chemistry classes, you will have to know them for those courses as well. So let's kind of go through the list. We have our cations and our common anions. So remember, a cation is going to have that plus charge right here, while the anions will have a negative charge to it. So the cations that we'll have to know are ammonium, which is NH4+, and hydronium, which is H3O+. So pretty easy, we only have two. Hopefully it won't be too hard to remember those. The anions, there's a lot more. So we have acetate, which is a very common thing that we use. It's CH3COO-, cyanide, which is CN-, hydroxide, which is OH-, hypochlorite, which is ClO-, chlorite, which is ClO2-, chlorate, which is ClO3-. So you kind of see the trend here. So we had hypo, which only had 1 oxygen, chlorite had 2, chlorate had 3. So hopefully that will be a trend that you'll be able to remember. We then move to nitrite, which is NO2-, and nitrate, which is NO3-. Permanganate, which is MnO4-. And then we move to the right side, we have carbonate, which is CO3-2-. Bicarbonate, which is HCO3-. So we notice that we added a hydrogen here, and hydrogens have a plus charge to them, so it took one of those negatives away. We have chromate, which is CrO4-2-, and dichromate, which is Cr2O7-2-. Peroxide, which is O2-2-. This is going to be something important to remember. Phosphate, which is PO4-3-. Hydrogen phosphate, which is we just added a hydrogen onto the previous one. And like I said before, hydrogen has a positive charge, so it takes one of those negatives away. And then finally, our last two, which is sulfite, SO3-2-, and sulfate, which is SO4-2-. So a few of them you noticed were oxoanions. So they're anions that have a oxygen attached. So for this given example or this table, I'm going to use chlorine as my element. Chlorine is an anion. It has that -1 charge to it. So what I'm talking about is we saw some that had like hypo, and then we saw the ones that had ate and ite. For oxoanions, not all of them kind of have the same general format, but a large majority of them do. It's going to be set up in this, this way to where they have a relationship. I call this my base because it's kind of just where I start off. So with your base, you're not going to have a prefix. It's going to be chlor, which is my root for chlorine, ate. So I have chlorate as my element, which is ClO3-. If I go up, so I'm adding an extra oxygen, I get per. So per is my prefix, root 8. So I have perchlorate, which is ClO4, so I added that 1 extra oxygen minus. So if I go back to my base and I take an oxygen away, I still have no prefix, but it becomes chlorite. So I switched the A for an I. So it becomes chlorite, and it's ClO2 minus. If I go for my base and take 2 oxygens away, I get hypo. So I get hypochlorite. So like I said, hypochlorite, which is ClO minus. However, because I went from 4, 3, 2, 1, it doesn't always fit that numbering. The best thing to do is to remember the base. So remember what your base looks like, so whatever your 8 looks like. So for example, if I have sulfate and sulfite, so sulfate is SO4 2 minus. So it's different, right? But it's still going to fit that same rule. So if I switch from 8 to ite, I take 1 oxygen away. So looking at it, I did just that. I went to sulfite and I took 1 oxygen away. So it fits the same rule, but you will have to memorize something. So you will have to know what its base is. So what it is when it has no prefix, but it has 8. So like sulfate, nitrate, polyatomic ions such as that. So I'm going to show you a video where they kind of show you all the relationships that they have for the polyatomic ions. Do keep in mind this video will show you a couple extra that you might not have to know for your exam, but just keep that in mind when we start to go through them.
You take a general chemistry class, you often have to memorize some of the common polyatomic ions. Let's go through a list of some of the ones that you might see in your class. So to start off with cation here, so a positively charged ion. NH4+ is called the ammonium ion. And for anions, there are many anions that you should know. CH3COO- is the acetate anion. Cn- is the cyanide ion. OH- is the hydroxide anion. MnO4- is the permanganate ion. And when you get to NO3- versus NO2-, look at the endings. So NO3- is nitrate, right? So we have an ATE suffix, an ate suffix here, which means more oxygens, versus the ite suffix, which means fewer oxygens. So we can see that nitrate has 3 oxygens and nitrite has 2 oxygens. And that ending is important because it's going to help you with the other polyatomic ions. For example, let's look at this next set here of 4. And let's look at chlorate, right? So chlorate has 3 oxygens. It's ClO3 minus 1. And chlorite has fewer oxygens. It has 2 oxygens here, ClO2 minus. So we have 8 meaning more and ite meaning fewer here. What about perchlorate, right? So here we have chlorate, but we've added on a prefix this time, and the prefix per means 1 more oxygen. So perchlorate means 1 more oxygen than chlorate. Chlorate had 3 oxygens, right? And for perchlorate, we add 1 on and we get 4. So perchlorate is ClO4 minus. Next, let's look at hypochlorite. So we talked about chlorite up here. So here's chlorite, and then we put a prefix hypo in front of it. Hypo means 1 fewer. So if we look at chlorite, we had 2 oxygens, right? We take 1 away, and now we have only 1 oxygen. So that must be the hypochlorite ion. You could have done this for a different halogen. Here we're dealing with chlorine, right? But let's say instead of ClO3 minus, let's do BrO3 minus. ClO3 minus was chlorate. Here we have bromine instead of chlorine. So this would be bromate, right? So there's another polyatomic ion. And we could do another example. So instead of ClO minus, which is hypochlorite, we could have had BrO minus, which would therefore be hypobromite, right? So this would be hypobromite. All right, let's look at our next set of polyatomic ions. All right, so let's get some space down here. So we have SO4 2- is called sulfate, right? So we have our 8 ending. And then we have 4 oxygens. So if we go to 3 oxygens, SO3 2 minus, this is sulfite, right? Because ite means fewer oxygens. What about if we took sulfate, SO4 2 minus, and we added on an H plus, right? So H plus and SO4 2 minus should give us HSO4, and then instead of a -2 here, instead of a 2 minus, we would just have a 1 minus because we added on a positive charge. Right, so 1 positive charge and 2 negative charges give us 1 negative charge. So HSO4 minus is called the hydrogen sulfate ion. All right, you might also hear bisulfate for this one. Next, CO3 2 minus is called carbonate. So if we add on an H plus to CO3 2 minus, we'd get HCO3, and then we go from -2 or 2 minus to -1 because we're adding on a positive charge here. So HCO3 minus is called hydrogen carbonate, and you'll also hear bicarbonate a lot. Next, we have PO4 3 minus, which is called phosphate. If we add on an H plus to phosphate, right, think about what we would get. We would get HPO4, and then instead of 3 minus, right, we're adding on a positive charge, so we get 2 minus. So we call this hydrogen phosphate. All right, let's add on a proton to hydrogen phosphate. So we're adding an H plus onto hydrogen phosphate. That would give us 2 H's, right, PO4, and we'd go from 2 minus down to 1 minus. So H2PO4 minus is called dihydrogen phosphate. All right, let's continue on. One more set of polyatomic ions to know. So we have CrO4 2 minus, which is called chromate. And if we have 2 chromiums, so Cr2O7 2 minus, this is called dichromate. Next, C2O4 2 minus is called the oxalate ion. And we have O2 2 minus is called peroxide. And here we have SCN minus, which we call thiocyanate. So thio, think about sulfur if you see thio there. So for our next one, right, we have sulfur present again. It's S2O3 2 minus, and this one's called thiosulfate. So you might see a few additional polyatomic ions in your class, but these are the ones that you see most frequently. So make sure to memorize your polyatomic ions.
All right, so let's go back to our presentation. So the reason why I'm showing you so many things for polyatomic ions is because it is such an important topic. And it's not a topic that we really cover in lecture. Your professors are normally just going to give you a list of polyatomic ions and expect you to have them memorized. So I'm going to show you a couple tools that you can use to actually help you in the process of memorizing and learning your polyatomic ions. So there's 2 tools that I'm going to kind of show you. The first is a program called Quizlet, and then the second is just some creative ideas of how to remember them. So I'm going to show you a video that they made a song to help remember polyatomic ions. So let's go to Quizlet. So this is kind of what it is. I highly suggest you make your own because, like I said, your professor can have you memorize specific ones. So if you just find one on the internet, kind of how I did, it can give you a lot more than you have to know, and it might not include everything that you do have to know. So it's Quizlet.com. And I just found one that had to do with common polyatomic ions. So this is kind of how it's going to be set up. So if you hit create, it'll pop up with 2 sections where you would type in the name and then you type in the formula on 2 different sides. And then you just hit create quiz and it'll pop up kind of like this. So there's a couple different programs that you can use to actually help you memorize the different polyatomic ions. So the first thing is flashcards. So it would pop up with the name or it would pop up with the formula and you would click and test yourself just kind of on what you would, it's kind of like having hand flashcards, but it's the electronic version of it. So if we go back, there's also learning. So if it can give you the formula, or it can give you the name. You tried typing it in, you test yourself, or you can hit I don't know, it'll put it back in the pile for you. There's spelling, if you want to know how to actually
hydroxide,
how to spell it. So it tells you the name, so you hear it. So if you're an auditory learner, it gives you the formula, it tells you the name, and you have to type in the name. So it's a very good tool for people that learn by listening. We then have a test. This is something very good to use. You can adjust the test to what you want in there. So there's a couple written questions, there's matching that you can do, multiple choice, and that's kind of it. So if you hit options, you can say, I don't want written, or I don't want matching, I don't want true and false, I just want multiple choice, or you can say, I want matching and multiple choice. You can adjust it to what you want on your test. And you just kind of keep doing it over and over again until you get something, get comfortable with the concept. There's also matching. So you start, it will time you, and you're just going to kind of drag and drop and try to like match things up. Does that make sense? And then finally, it's kind of like a game. So you say, get started. You can choose easy, medium, or hard. You say, let's go. You're going to watch out for the asteroids. So you have to type in your compound. So you would type in the formula for carbonate before the asteroid hits the planet. And so it's kind of, that's kind of how you play this one. So this is what Quizlet has to offer. I think it's a very helpful tool on anything that you have to help memorize. And then finally, like I said, creative ways to help you remember polyatomic ions. So I'm going to show you, it's just a brief little video. It's kind of funny, so maybe it'll help you remember.
I mean, so an ionic compound has a metal and a non-metal, right? So a molecular compound, you know what I'm saying, has to have two or more non-metals, right? Okay. So what we learning? Polyatomic ions, you know those electrically charged species formed by covalent bonds of atoms, you know what I'm saying, of two or more elements? Yeah, that's the, yeah. Oh, yes, yeah. I'll show you how it's done right now. Yeah, NH4 is ammonium, man. H3O is hydronium, and both of them, man, have a positive charge. The test is coming soon, so know who they are. What about cyanide? That's the N. What about hydroxide? That's OH, and both of them are negatively charged. Once again, just know who they are. Now moving on, just listen to the pro. Hypochlorite is ClO, not to mention it is negatively charged like chlorite, which is ClO2. But moving on, man, I'ma do this real great. ClO3 is chlorate. ClO4 that's perchlorate, negatively charged, and it is real great. Now we gonna do it real tight. NO2, yeah, that's nitrate. NO3, that's nitrate. Both negatively charged, real great. So is permanganate, MnO4. So is bisulfate, HSO4. So is bisulfite, HSO3. So is bicarbonate, HCO3. I think I know this. I know this. These polyatomic ions, I'm focused. I think I know this. I know this. These polyatomic ions, I'm focused. Okay. Now let me see if you know the negatively charged polyatomic ions. Let me see what you got. Carbonate, CO3, chromate, CrO4, sulfite, SO3, sulfate, SO4, peroxide, yeah, that's O2, like chromate, CR2O7, 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 hydrogen phosphate, HPO4, what about phosphate, PO4, what else about phosphate? It's a part of my lectron, it has about 3 extra electrons. I think I know this, I know this. These polyatomic ions, I'm focused. I think I know this. I know this. These polyatomic ions, I'm focused. I think I know this. I know this. These polyatomic ions, I'm focused. I think I know this. I know this. These polyatomic ions, I'm focused. Y'all know who it is.
All right, so if you are interested in knowing what this is, it's AP Chemistry, Polyatomic Ion Wrap. There's also other videos that you can find, and it's just different types of videos that if you're into music and you want to know ways that music can help you learn your polyatomics, just search on YouTube and you'll find it. All right, so let's go through an example. So this is a type of example that you could see where it's simply asking you about the polyatomic ions. A majority of the questions that you will have on your exam, it will be incorporated into another question. But let's go over just a basic polyatomic ion question. Which of the following names and formulas of ions is correct? So we have SO3, 2-, which is sulfate, NO3-, nitrite, and NH4+, ammonium. So let's go to our boogie board so that we can talk about each of these. So they said that we have SO3, 2-, NO3-, and NH4+. They told us that this is sulfate. They told us this was nitrite. And they said that this was ammonium. Well, 2 out of these 3 are incorrect. So it would be your job to figure out, okay, which one is not correct. Sulfate is going to have 4 oxygen. So SO3, 2- is going to be sulfite. So sulfite is SO3, 2-. So we know this one is not correct. Nitrite is actually NO2-. So, sorry, just kidding. No, correct, yeah. So nitrite will have less than this, all right? So, which means NO3- is going to be nitrate. So nitrate is NO3-, nitrite is NO2-. So we know this is not correct, which kind of leaves us with our last one. But yes, if we check on our list, ammonium is going to be NH4+, so correct. So really it's just memorization. Make sure you actually learn them and don't just try to cram it in last minute. The next concept we're covering is chemical bonds, the first being ionic bonds. Ionic bonds are formed between ions with opposite charges. For instance, positively charged sodium ions and negatively charged chloride ions attract each other to make sodium chloride or table salt. Ionic bonds is the transferring of electrons from the atoms of one element to those of another. So it's going to, one of them will give its electron away. And an ionic bond is going to be the bond between a metal and a nonmetal. So here is a visual representation of an ionic bond. So we have our Na, which they said when we combine that with Cl, we're going to produce salt. So you see the electrons around the sodium are red, the ones around the chlorine are black. We see that for them to form that bond, the sodium had to give its electron away to chlorine to be able to form that bond. So it transferred its electron over, and that would be a ionic bond. The next one is covalent bonds. Another way atoms can become more stable is by sharing electrons rather than fully gaining or losing them. thus forming covalent bonds. Covalent bonds are more common than ionic bonds in molecules of living organisms. Covalent bonds is the sharing electrons between atoms of different elements, and it's going to be two non-metal elements. So this is kind of what a covalent bond will look like. So we have our carbon, our oxygen, and the oxygen and carbon are sharing their electrons with each other in order for them to form that bond. And then we're kind of backtracking back to ionic compounds. So an ionic compound will have ions. Ions are charged particles that are a result of losing or gaining one or more electrons. And so there's two types of ions. There's positively charged ions, which is what we talked about when we discussed polyatomics. There's negatively charged ones, which are we also talked about where we had more of them in the polyatomic ions. So the positively charged ones are something called a cation. They're positive charged ions, atoms that are going to lose electrons. For example, our sodium. So we have a plus sign on here, which means it's a cation. If we have an anion, it's going to be a negatively charged ion, and it's when an atom will gain an electron. So remember, electrons have that negative charge. So by getting more electrons, something that was neutral now has a negative charge to it. These ions interact via electrostatic forces. So this is just kind of a funny picture that will help you maybe memorize that one is positive, one is negative. So we have our little cat. It says cats are good, so they're positive. So we have a cation. Another way that you can remember it is cations are positive. So cats have pos, they're positive. And then anions, it kind of looks like the word onion. So if you take the A out and put an O, you see onions. So onions are bad, so they're negative. So anions are bad or negative. So let's go through an example to see if you understood. When an atom has lost an electron, it becomes a blank and has a blank charge. So you have to pick which one of these is correct. So let's go to our boogie board so that we can work it out. So it said, when an atom lost an electron, it becomes a blank and has a blank charge. So they gave us all the combinations of cations, anions, positive and negative. So what we know is that electrons are negative, because this is kind of what they look like. So electrons are negative. If I have an element, let's say hydrogen, it's just a neutral element right now, and I'm going to take one away. So I'm taking my electron away. It becomes positively charged. So by losing an electron, it becomes positively charged. If it's positive, so remember, blank ions are positive, so I know it's spelled weird, but positive. So remember which one has pos. Cations have pos, so it would be a cation, and it has a positive charge by losing an electron. So that one would be B. So B would be our answer. Now let's go to our next example. Is sodium oxide, which is Na2O, an ionic or covalent compound? So let's go to our boogie board. So we have Na2O, and we want to know if it's ionic or covalent. So what is it to be ionic and covalent? Well, ionic is going to be a metal, so I'm going to represent that with an M, and a nonmetal. And then for covalent, it's two nonmetals. So we have to figure out which or what they are pretty much. So is sodium and is oxygen a metal or a nonmetal? So let's go to our internet. We'll type in ptable.com and we can check. So let's highlight nonmetals. So as we can see, oxygen is highlighted as a nonmetal. And then we find sodium. Sodium is highlighted when we go to metals. So sodium is a metal. So we can use that information to determine which one we have. So we're dealing with sodium, which is a metal, and oxygen, which is a nonmetal, which means that our compound is ionic. So pretty simple, not very hard to be able to determine what we have. And then finally, we're going to talk about isotopes. Isotopes are variations of chemical elements that have the same number of protons, but different number of neutrons. We identify isotopes based on their mass, whereby the sum of protons and neutrons equals the mass of the isotope. So here is just a visual representation of what the carbon isotopes are. So the neutrons will differ, but the mass will change. Neutrons will differ, which changes the mass. So remember, your mass is your protons and your neutrons together. So as we see, the protons are the same for each one. This number up here that is at the top is our mass number, which is protons plus neutrons. So we can see that as we move up, the number of neutrons is changing. So protons are the same, neutrons are different, which means all of these are isotopes of each other. So let's go through a more vague example. So atoms X, Y, and Z have the following nuclear composition. So we have X, which has the 210 at top, 186 at bottom, Y, 210 at top, 185 at bottom, and Z, 310 at top, 186 at bottom. They want to know which of the following are isotopes. So let's go to our boogie board to discuss. So they have it set up in the format of X, A, Z, where this is our symbol. Sorry, kind of cut it off right there. But that's our symbol. A is our mass. And Z is our atomic number. So remember, your atomic number is going to have only protons, while your mass has your protons plus your neutrons. So remember, protons are the same, so our bottom number should stay the same when we have an isotope, but our neutrons will change, which changes our mass. So we have the mass changing. So the top number will differ. The bottom number will be the same. And that is for it to be an isotope. So let's kind of look at what we have. So we have X, Y, and Z. 210, 210, 310, 186, 185, 186. So these are the compounds that we have. So we know that the top needs to be different. So automatically we know these two cannot be isotopes because their top number is the same. But we don't know if Y and Z are isotopes or X and Z are isotopes. So we have to look at our bottom. Our bottom has to be the same. So these two cannot be isotopes because their two bottom numbers are different, which means that X and Z are isotopes. So going back, we look for X and Z, which is going to be B as our answer choice. And that's pretty much everything that we have to cover today. So let's go over a brief overview of everything we talked about. So we talked about polyatomic ions. I showed you the general list of the polyatomic ions you're most likely to have to memorize. But do take into account that it's all based off your professor. So if there's certain ones that your professor wants you to know that weren't on that list, make sure you add them to it. We also talked about different tools that you can use, such as Quizlet or YouTube, which has a bunch of videos, or you can go old-fashioned and just do basic note cards. We also talked about chemical bonds, such as ionic and covalent bonds. So remember that if it's ionic, it's a metal and a nonmetal. If it's covalent, it's going to be two nonmetals. Also, in ionic, we talked about cations versus anions. So remember, cations are positive. Anions kind of look like onion, so they're negatively charged. And then finally, we talked about isotopes. So for it to be an isotope of each other, the number of protons must remain the same, so the atomic number has to remain the same, but the neutrons will differ. So one will have more than the other. So that means that the actual mass of the isotopes will be different, but the protons or atomic number will be the same. That is all I have for today. I hope that this video is helpful and that the tools that I showed you will be useful. Thank you and best of luck.